Hi class, let's take a look at example 2. Now in example 2, they're giving us two lines in space, and notice that you technically have a point and then its associated vector, and they want to see if, well, they want us to find the intersection. So your lines are going to intersect if the following is true from each of the actual points and vector associated. So for instance, your x's, your x values, if there's an intersection, so you're going to have that your x values, you're going to have 1 plus technically 2t has to be equal to 1 plus the values of 3s. So I'm pairing up the point of the x's for each lines. Your y value would be 2 plus negative t. And this is equal to, on the right hand side for the second line, you don't have an s vector, so just -1. And then your z coordinate, you would have 3 plus the values of t. This is equal to 4 plus the values of s. So we end up with a system of equations. Let me double check. Okay, so we end up with technically equation 1, equation 2, and equation 3. And notice that from equation 2, so from equation 2, you technically have that 2 minus t is equal to -1. Or if we subtract the actual 2, so subtract 2, negative t is equal to -3, or t is equal to the values of 3. Now at this point, once you identified one value from the system, then now we can find the actual value of s. So let me write it as find s. And then your s value, you can plug it into any of them. In this case, let me plug it into equation 3. So 3 plus t So 3 plus t, this has to be equal to 4 plus s. So 4 plus s, and plugging in 3. In this case, we already have a value for s, for t. So this will be 3 plus 3 is equal to 4 plus s, or 6 is equal to 4 plus s, and then I can subtract the 2's, and this is gonna now give me that your s value is equal to 2. Now for the system of equations, we already found your two values for the vectors where the lines intersect. So let me just write it as we found that t is equal to 3, comma, s is equal to 2. And also, because there are multiple cases, you want to check both to make sure that yes, we found the point of intersection. So in this case, your x value is going to be as follows. So x is going to be equal to 1 plus 2t, or 1 plus 2 times 3. I'm getting 7. Your y value, we're going to have y is equal to technically 2 minus t, or 2 minus the values of 3. We're going to be getting -1. And then your z coordinate, it's going to be 3 plus t. So z we're getting c is equal to 3 plus t, which is equal to 3 plus 3. This is equal to 6. Now, in this case, we still have to check the s is equal to 2 to make sure we found the intersection. Let me write the answer and then we'll do a quick check. So the intersection occurs happens to be at x, y, and z. In this case, 7, negative 1, and 6. Now, you still have to do a check to make sure there's no errors. Or we have one of the other cases. So if we look at s is equal to 2, I'll just check it on the side. And remember that for the second line, you're checking s. So s is equal to 2. We already have your, technically your y value. So y is equal to negative 1. Your z value, it's going to be 4 plus 2, which is 6. And then your x value is equal to 1 plus 3s, or 1 plus 3 times 2. And in this case, we're looking at 7. So once again, you do have to check it to make sure there's no errors. You're looking at 7, negative 1, and 6. So in this case, this one checks out. Like I said, we just want to double check that we did find the coordinate point of the intersection. And in terms of type of questions, they could simply ask us to find the intersection. If there had been no intersection, we would have found a contradiction here, or when you plugged it into this portion. That's actually it for example 2.